Pediatric Dentist channel Tiny Tip Talks. If you are new to this channel, subscribe the channel, and for details of this channel visit the bio section, or you can also check out my first video. Sorry if there is any mistake in videos or shorts. Today we will discuss the remaining theories of tooth eruption. So the seventh theory is the foreign body theory. Gottlieb suggests that a calcified structure like a tooth is treated by the surrounding tissue as a foreign body, and according to this theory the tissues respond to the tooth in a manner similar to how they would react to any foreign object, leading to its exfoliation or movement into the oral cavity. But unlike true foreign bodies, teeth are not extraneous objects but are integral part of the body, developed within the alveolar bone and supported by periodontal ligaments. Experimental models have shown that the teeth can erupt even in the absence of inflammatory responses, further disproving the foreign body theory. The eighth is cellular proliferation theory. Noyes observed the plants generate tremendous pressure through the cellular proliferation, allowing them to break through the hard obstacles like soil or rocks. He proposed a similar mechanism for the tooth eruption. In this theory, the proliferation of the cell in the dental pulp and surrounding tissue creates osmotic pressure and mechanical forces. These forces are thought to push the tooth upward into the oral cavity. Cellular proliferation, which is cell multiplication in the dental pulp and which create the osmotic pressure and mechanical forces. So, in the dental pulp, the cells like fibroblast and undifferentiated mesenchymal cells actively divide and multiply. This rapid cell multiplication increases the number of cells in a confined space, leading to a physical pressure within the pulp which create the force that are thought to push the tooth into the oral cavity. But there is no direct evidence to support the idea that the cellular proliferation in the pulp generates sufficient force for the tooth eruption. Coming to the vascularity theory, Constant in 1896 emphasized the role of the rich vascular supply in the tissue surrounding the developing tooth by the gingiva, periodontal ligament, alveolar bone, etc. have nerves and vessels. According to this theory, the blood pressure within these vascular tissues generate a mechanical force that drives the eruption of the teeth. While vascular pressure may contribute to the eruptive process, it is unlikely to be the sole driving force. Modern research has shown that the tooth eruption is a multifactorial process involving the dental follicle, alveolar bone remodeling, and molecular signaling pathways. Then the blood vessel thrust theory. So the eruption of the teeth is influenced by the blood supply to the developing tooth, similar to the vascularity theory. This theory posits that the hydrodynamic and hydrostatic forces generated within the blood vessel surrounding the tooth provide the mechanical force necessary for the tooth eruption. Hydrodynamic forces. So these are forces generated by the movement of the blood through the vessels. The pulsatile nature of the blood flow could theoretically exert rhythmic pressure on the surrounding tissue, and hydrostatic forces, these are the static pressure exerted by the blood within the vessels. Increased vascular pressure could create a steady force that could contribute to the tooth eruption. While vascular changes are observed during the tooth eruption, there is no direct evidence to confirm the hydrodynamic or hydrostatic forces are the primary drivers of the process. Coming to the periodontal ligament contraction theory. So the periodontal ligament is a specialized connective tissue that anchors the tooth to the alveolar bone. It contains fibroblasts, collagen fibers, and extracellular matrix components. So according to this theory, fibroblasts within the periodontal ligament exhibit contractile properties, generating traction force that contribute to the tooth eruption, and these forces are thought to act on a collagen fibers, creating a pulling mechanism that moves the tooth upward into the oral cavity. When the fibroblasts contract, they physically grip the collagen fibers and apply a pulling force, creating a tension generates the traction force that help move the tooth gradually upward through the alveolar bone and surrounding tissue. A laboratory model was developed to mimic the cryptic bone and periodontal environment. This system consisted of a well lined with a perforated mesh containing a gel plated with the fibroblast and a slice of a root dentin. The fibroblast established a three-dimensional network and generated sufficient force to raise the tooth slice from the bottom to the top of the well. So these experiments provide a direct evidence to the contractile capabilities of the fibroblast in generating erupting forces. Tooth eruption is now understood to be a multifactorial process, and the periodontal ligament contraction theory represents only one aspect of this complex phenomenon. Coming to the dental follicle theory. So the dental follicle theory emphasizes the critical role of the dental follicle in the tooth eruption. The dental follicle is a loose connective tissue that surrounds the developing tooth germ. It plays a pivotal role in the coordinating the bony remodeling necessary for the tooth eruption by regulating the activity of the osteoclast and osteoblast. How? So the dental follicle produces signal signaling molecules such as a colony stimulating factor CSF1, monocyte chemoattractant protein 1 MCP1, which recruit the mononuclear cells to the eruption site, and these cells differentiated into osteoclasts, which resorb the alveolar bone to create an eruption pathway. The dental follicle also provide the microenvironment necessary for the differentiation of osteoblasts, which deposit new bone to stabilize the erupting tooth. Key signaling pathways such as the Rankel pathway are activated within the dental follicle. Rankel promotes the osteoclastogenesis, while its antagonist OPG regulates the balance between the bone resorption and formation. Coming to the bony remodeling theory. During the pre-eruptive phase, the jaws undergo selective bone deposition and resorption to accommodate the movement of the developing teeth. Bone resorption occurs in the areas where the tooth needs to move, while bone deposition stabilizes the tooth in its new position. This process is regulated by osteoclast and osteoblast, which are influenced by local and systemic factors. Studies have shown that when the tooth gum is replaced with a metal or silicone replica and the dental follicle is retained, the replica erupts within the formation of an erupting pathway. This demonstrates that the dental follicle promotes the remodeling process even in the absence of the developing tooth. Summary, the foreign body theory suggests that the tissue respond to the tooth in a manner similar to any foreign object, leading to exfoliation or movement into the oral cavity. Cellular proliferation theory said that the proliferation of the cell in the dental pulp and surrounding tissues creates osmotic pressure, and mechanical forces are thought to push the tooth upward into the oral cavity. Vascularity theory emphasizes the blood pressure within the vascular tissue generates the mechanical force that drives the eruption of the teeth. Blood vessel thrust theory, also similar to the vascularity theory, emphasizes that hydrodynamic and hydrostatic forces generated within the blood vessels surrounding the tooth provide the mechanical force necessary for the tooth eruption. Periodontal ligament contraction theory suggests that the fibroblasts within the periodontal ligament exhibit contractile properties, generating traction forces that contribute to the tooth eruption. The dental follicle theory suggests that the dental follicle produces signal molecules recruit mononuclear cells to the eruption site. These cells differentiate into osteoclasts, which resorb the alveolar bone to create an eruption pathway. Bone remodeling theory suggests that during the pre-eruptive phase, the jaws undergo selective bone deposition and resorption to accommodate the movement of the developing teeth. The tooth eruption is a multifactorial process. No single theory fully explains it, but the combined insights from this perspective suggest that eruption is the result of a tightly regulated interaction between biological signals, cellular activity, and mechanical forces. Each theory provides a piece of the puzzle, emphasizing the importance of collaborative processes in guiding a tooth through its eruption path. These are the references. If you want this PDF or any other PDF, just like, subscribe, and comment your mail ID with the topic, and I'll send you the PDF. New videos on Sunday or sometimes Thursday and Sunday. Also, we try to put MCQs according to topics on our shorts with the answer and explanation if needed, which will help you in Viva or NEET exam. Like, share, and subscribe the channel. Thank you.